Hello and welcome. In this video, we're going to talk about Microsoft Excel and how we can use it to help us calculate simple formulas to work on our lab reports in physics. Now, I've already have this set up, and I'm going to show you how to fill in this kind of information so that it will do the work for you. Now, before we start, I want to draw your attention to this little button right up here at the top, the little question mark. This is the help button. If there is any kind of formula that you think that could possibly Excel work on, or any formula that Excel might help you with, go to that button, click it, and type it in what you want it to do. Chances are Excel can do it. Excel is a very powerful software that will help you calculate, help you sort, help you average, almost anything. And so make sure you pay attention, and if you have any questions, click this little help button. It is a lifesaver. It is what I always go to help me determine proper formulas. Okay, so let's go ahead and get started. So we have an activity that I did where I wanted to see how fast the ball is shot out of a projectile launcher. And so I went ahead and collected some data, and this is a picture of what's happening. I had a meter stick, and I measured as the ball left the projectile launcher how high it went. Now, some things we need to assume is that at the top, the velocity at the top of any projectile's motion is going to be 0, and that the acceleration of a projectile on Earth is always 9.81 meters per second squared down. Okay, and so that's what this negative sign means. And so the activity is set up in this situation, and here's the data that I collected for my 6 trials. I tried 6 trials just to make sure that I had proper data. Now, if you notice, one thing that you notice here is I did not include an uncertainty, because my uncertainty, whenever I take a range of values or multiple trials, is actually determined by some other aspects. These are formulas over here. And so we're going to go ahead and talk about and work through these formulas using Excel and have them do the work for us. Now, the first thing I want to do is I want to get the average of my values. And so I click on this box because I labeled it my displacement, or my average displacement. And so in order to enter in a formula into Excel, you always start with the equal sign. So you put equals, and it tells, hey, Excel, I'm going to put something in that I want you to calculate. So I want this cell to equal, well, the average of my values. So I'm going to click type in average, and then open parentheses. Now, if you look here, it tells me this is the average function. And then it asks me for the numbers, the 2 numbers, or the multiple numbers that I'm going to use. Now, I can either click individually, or I can actually just highlight the range. And if you see here, it gives me the format of cell C7 through C12. And so I want to know what's the average of those numbers. And it spits out the average. Now, this obviously is too many significant digits. But there's a thing whenever I take the average of multiple trials that I cannot get rid of significant digits until the very end. And so that's what this column over here for is significant figures. And so using this column is where I'll actually get all my information for calculations. Now, the first thing here that I need to deal with whenever I'm dealing with multiple trials and information for multiple trials is this R, which stands for range. And so the range is going to be my maximum value minus my minimum value. And so in Excel, I can type this in as equals my maximum value, open parentheses, telling Excel that I want you to find the maximum value in this set, minus the minimum value in this set. All right, and so right now I only have 6, and so it's easy to pick out the maximum minimum. I can do that just off the top of my head. But let's say I had 1,000 different values. So I did 1,000 trials. How do I pick out my minimum and my maximum? This is the easiest way. Now, it tells me that my range, or the distance between my minimum value and my maximum value, is 0.04 meters or 4 centimeters. Once I figure out my range, then I can figure out my uncertainty. Now, this uncertainty is the uncertainty for each individual trial. Okay? Even though I measured to centimeters in each trial, that is not my uncertainty in the fact that it changes or it varies so much. So what I need to do is I need to tell it that my uncertainty is going to follow my range divided by 2. So I'm going to click equals and click on my range box, which is cell F6, and I'm going to divide that by 2. So this tells me that my uncertainty for each of these values is plus or minus 2 centimeters. Now in order to figure out my average, or what is my uncertainty for all of these. So if I were to average these, this average right here, what would my uncertainty be for that? Well, that is going to be my range divided by 2 times the square root of the number of values, or my actual uncertainty for each individual trial divided by the square root of the number of trials. And so I'm going to enter that in as equals, well, my uncertainty, 0.02, cell F7, divided by, and then the square root function is SQRT, which stands for square root. And I want to know the square root of the number of values. All right, using the number of values. Now, once again, I have 6 on this case, and so 6 is very easy to enter. But let's say I have 1,000 or 1,253. Now, I'd have to count all of those, or I could just do a count function, all right, where it counts all of the values that I have. And so I type in count, and then it says count the number of values I have in cells C7 through C12. And so this part of the function is just going to count that number. And then the square root part is going to take the square root of that number. And so there is my average uncertainty. Now, because all of my my delta S has only one significant digit, I can only keep one significant digit here. And so this becomes 0.008 as my significant digit there, or as my uncertainty. Now, what does that mean? It means that although I've only measured to the centimeters, in this case, or plus or minus 0.01, because I've conducted multiple trials, I actually have a significance all the way out to the thousands. And so this is where I'm going to go back and I'm going to type in 1.457. All right, so my by taking the average or taking multiple trials, I actually decrease my uncertainty, which then increases the accuracy of my values. And so my actual average is 1.457 meters, or 147.7 centimeters. And so my uncertainty is actually, or my significance is actually more or greater than what I actually originally measured. All right, my uncertainty for each individual one is going to be the one significant digit also. So here we go. I put that in, and it auto-populated. Now, that's something that I can show you how to do. It's not something that's really important for you to be able to do in Excel, and so I'm not going to show you how to do it right now. It also auto-populated my final answer here. So my final answer, or my average displacement in a vertical direction, is 1.457 meters plus or minus 0.008 meters. Okay? Now, I want to get the percent average just because I'm going to need that later. And so this is the relative uncertainty. And so in order to figure out the relative uncertainty, I have to take my uncertainty and divide it by my actual value and then multiply that by 100. And it gives me my percent uncertainty, or my relative uncertainty is 0.549. And I'm allowed to have one significant digit, so it's going to be 0.6%. Okay? So this is my absolute uncertainty, and this is my relative uncertainty. This is percents, and this is in meters. Okay, so that is very simple how to enter in information into Excel, or how to enter in formulas into Excel. Hit the equal sign, type in the formula that you want, and then the range of information that you want it to use to calculate goes in parentheses. And you can stack these however many deep you need until you get what you know, such as in this case where I did the square root and the count. Okay, now that I know that my uncertainty and my average height of the ball, now I want to calculate the initial velocity of the ball, or the ball as soon as it leaves the projectile launcher. Some things that I need to note is that I need to have some information such as my absolute uncertainty, my relative uncertainties. So here I have it for my height, and then I have my relative uncertainties for my acceleration. Now, the equation that I'm going to use to solve for my initial velocity is one that we have, one of the kinematic equations, which says that my final velocity squared equals my initial velocity squared plus 2 times my acceleration times my displacement. And whenever I rearrange that, because my final velocity is 0 at the top of the height, I get a square root of -2 times the acceleration times the displacement equals my initial velocity. So I'm going to go ahead and type that in. And so it's going to be equals the square root, open parentheses, -2 times my acceleration, which is -9.81, times my average of my displacement. So my average is this 1.457 meters. And then I'm going to close parentheses, and it's going to give me this number. So my initial velocity is somewhere around 5.3466%. Now, my absolute, my relative uncertainty, because this is multiplication, I have to add the relative uncertainties. Well, it's going to be, well, the square root, what I actually am going to do with the square root is following this uncertainty rule, which says that the square root of an uncertainty equals 1/2 of that uncertainty. Okay? So, so I go ahead and look here. Well, my uncertainty of my acceleration is 0. Hold on. Let's go ahead and do this in parentheses because I'm going to be adding and multiplying. So it's 0.1% plus the uncertainty of my height, which is 0.6%. And then because it's a square root, I need to multiply that by 1/2. So times 0.5. And so that gives me my relative uncertainty of the velocity as 0.35%. So now I need to convert that to my absolute uncertainty. And so to convert to absolute uncertainty, well, all I do is I take my relative uncertainty and I multiply it by my actual value. And that's going to give me 1.87. Now, because this is a percent, multiplied by the average value, I need to take this 0.35 and I need to convert it into a decimal point. And so in order to do that, don't forget to divide that by 100. Okay, so whenever I divide it by 100, it actually turns it into 0.0035, which is 0.35%. And so this is my absolute uncertainty. And so if I go significant digits, I'm allowed to have 1 down here in my absolute, because if I look at my originals up here, these all had 1. And so I should have only kept 1 here. So 0.4. And so let's go ahead and redo this so that it's, instead of C17, let's put it at this. Let's move it over to the 0.4. All right, and so here is my absolute uncertainty, more appropriately using proper significant digits. And I have 1, so I'm allowed to keep 1. So 0.02 is my absolute uncertainty. And then, so this is significant out to the hundreds place. And so this is going to be 5.35 meters per second. And so here my final answers consist of my average height of being 1.457 plus or minus 0.008 meters. And my initial velocity has a value of 5.35 plus or minus 0.02 meters per second. Okay, so those are my uncertainties, and this is how we enter in those calculations.